One last Dr. Ben update for the day. Why the heck not? This is again immunology, not at all my strong suit at all. But let's do our best, right? Yeah. Let's see. So what this is looking at is this is now finally a relatively large study of a lot of people who have COVID or have recovered from COVID and mild and severe. And they are clinical isolates from people taken when they were actually infected, and also from some of these people after recovery, or from different people after recovery. Actually, I think they're separate points. And what they're looking at in this paper is what immune response did they make. And again, this is a preprint on bioRxiv. And I'll send Nicola the link so she can, I don't know, post it somewhere. I don't know how that works. So there is a lot just in a little part of figure 1 and 2. I think that's what we'll mention. So figure 1, like if you had an immunological wish list, what would you put on it? What sort of immune response would you like to make? And I think for most of the immunologists out there, they'd say, well, okay, if I had a choice, I would maybe have a moderate to low sort of neutrophil count. They're sort of crazy little maniac white blood cells that will they'll deal with problems, but they deal with problems by blowing stuff up. So yeah, you just got to keep them under a little bit of rain. And you'd say, well, probably I'd like to have a lot of antibody-producing cells. So those are called B cells. And probably, dear Santa Claus, I would also like to have a real nice T cell response, both helper T cells and killer T cells. Because, I know about viruses, and those are particularly important for controlling pretty much any virus that you can think of once it's actually infected the body. The antibodies will protect you from getting infected, and they'll kind of slow things down for the virus in some cases. But you need those cells. You need those worker cells to actually get the job done. And so, what do we get in SARS-CoV-2? Pretty much the opposite of everything you wished for. Yeah, Christmas is canceled. I guess. Not really. Yeah. So they show that there is massive sort of upregulation, growth of these neutrophils, which is bad. Yeah, because you don't want them running the show. Eosinophils are another one. This is why you take a lot of your allergy medication, is to tell eosinophils to just, tone it down a little bit, something like that. So that's okay. B cells are interesting. So these are the ones that make antibodies. They are about the same in people with moderate COVID and people that recover from COVID, but people with severe COVID, they're real low. It's the same thing with all the T cells. In people with moderate COVID, got pretty good T cell response. In people with severe COVID, bad T cell response. This is very much what was predicted from some studies on original SARS coronavirus a couple of years ago. And it's playing out as expected, which is, I guess, I don't know, intellectually comforting, but not a whole lot of real world comfort there for that one. And so the other thing that they look at so many things in this paper, but we're going to nitpick little tiny nits. The other thing they look at is antibody development. And what they find is that antibody development is actually stronger. So you get more antibodies in general in people with severe COVID. So the immune system is trying. It's just that massive amounts of antibody on their own, and the ones they're looking for are called IgM and IgG. These are, IgM is baby's first antibody. Antibodies go through this progression. And IgG is right at the middle. This is midlife stride for antibodies. This is the main one that you would find in your blood, and there are several different subtypes of it. And I think they're all being lumped together in this one. They probably used an assay that can't tell the difference between the types, and we don't really care about the difference. But the other thing that's in this chart are that there are several little dots that are right down on the 0 line in terms of antibody, and these are from people who have active infections, mild or severe, but have had enough time that they probably should have developed at least some antibodies. So quite variable, the number of antibodies you develop. And in the people that recover, Uh, some of those have, again, pretty variable antibody levels. They're kind of centered around 4 micrograms per mil, which is equivalent to about 4,000, which kind of squares with what we've seen, 1 to 4,000 dilution, rather, which kind of squares with what we've seen for other convalescent patients. So, yeah, this is backing up what we saw from some of those other, even much smaller studies than this. I mean, 54 infected people doesn't seem like a lot, but compared to what we've been getting in sort of the single digit numbers, this is pretty darn good. Yeah, and we'll take it for now. And wow, the a level of detail in here. It's going to take me most of the week, I think, to fully absorb what I can from all of this. But yeah, it looks like really nice work. I expect it to be coming out in a pretty high profile journal, coming to a journal near you. Yeah, in not too long. And it just shows the weakness in our immune defenses. The virus is shutting down the smart part of our immunity and letting the innate immune system and all these goofy white blood cells that just sort of trash the house, it's letting those run wild. And that's what the cytokine storm is. That is exactly what that disease is. And yeah, even if you're in it and even if you survive it, the results are pretty variable in terms of how much antibody you're going to have around that may give you some long-term protection. They don't ever look at the one antibody, it's called IgA, that would be most protective against a second round, because that's kind of hard to sample. You sort of have to scrape it off in a big blob of mucus from the inside of the lungs or something like that. And so people tend to just prefer to give like a little drop of blood to do these assays. So there you go. All right. That is our Dr. Ben updates for the day. Thank you very much. This has been Dr. Ben. I already said that. That's redundant. I am redundant. Thank you very much. Bye bye.